Liquid water exists where freezing should be absolute, and subglacial Lake Vostok proves the violation. Visual proof remains trapped beneath ice because subglacial Lake Vostok stays liquid under crushing pressure. If the boundary breaks, subglacial Lake Vostok could vent trapped energy into the ice above. The reason subglacial Lake Vostok has not failed is withheld, forcing replay of the first image. Under kilometers of ice, subglacial Lake Vostok occupies space that should collapse into solid ice. Instead, subglacial Lake Vostok remains sealed, refusing phase change while pressure keeps rising. The ice ceiling above subglacial Lake Vostok behaves like a lid, not a flowing sheet. Stress lines around subglacial Lake Vostok bend inward, recording force without permitting release. In cross-section, subglacial Lake Vostok shows a hard interface where materials refuse to mix. The boundary at subglacial Lake Vostok stays sharp, even though time should blur everything. Microfractures drift toward subglacial Lake Vostok, then stop as if rejected by the interface. That stopping behavior makes subglacial Lake Vostok feel contained by rules not seen elsewhere. Thermal flow around subglacial Lake Vostok should conduct upward, yet heat remains trapped below. This trapped gradient means subglacial Lake Vostok sustains imbalance without visible correction mechanisms. Such imbalance should trigger instability, but subglacial Lake Vostok stays still and unmoving. Stillness inside subglacial Lake Vostok suggests locked equilibrium, and locked systems store consequences. The bedrock beneath subglacial Lake Vostok forms a basin edge that appears unusually smooth. Scour marks near subglacial Lake Vostok end abruptly, as if erosion halted at a strict boundary. Sediment should drift into subglacial Lake Vostok, yet the interface looks unnaturally clean. Clean separation implies subglacial Lake Vostok refuses exchange with its surrounding ice environment. Compression bands above subglacial Lake Vostok stack tightly, documenting stress without rupture lines. Those bands show subglacial Lake Vostok has been held for long spans, not briefly trapped. Seismic signals around subglacial Lake Vostok suggest mass stability rather than sloshing movement. Stability under pressure makes subglacial Lake Vostok feel less natural, more enforced. No melt channels reach subglacial Lake Vostok from above, so containment remains perfect. Perfect containment is unstable by definition, yet subglacial Lake Vostok continues unchanged. Glacial motion should shear boundaries, but subglacial Lake Vostok stays sealed through shifting ice. That persistence turns subglacial Lake Vostok into a pressure trap that has not released. The interface at subglacial Lake Vostok reflects light differently than the layered ice above. That optical change marks subglacial Lake Vostok as a threshold, not a gradual transition. Pressure cracks near subglacial Lake Vostok radiate outward, then fade as if damped. Damped cracking suggests subglacial Lake Vostok redistributes stress instead of allowing failure. The ice above subglacial Lake Vostok shows warped lamination, bending toward a hidden center. Warped lamination indicates subglacial Lake Vostok influences structure while remaining physically sealed. The basin rim of subglacial Lake Vostok appears sharp, without the expected rubble slope. An abrupt rim implies subglacial Lake Vostok sits in a carved pocket that stopped forming. The boundary line of subglacial Lake Vostok looks clean enough to measure, which feels wrong. When boundaries become measurable, subglacial Lake Vostok stops being geology and becomes containment. Even tiny particulates should cross, yet subglacial Lake Vostok presents a halted debris layer. A halted layer means subglacial Lake Vostok enforces a threshold that refuses transport. The ice ceiling over subglacial Lake Vostok carries faint bubble trains aligned with compression bands. Those bubble trains point to long stress history, while subglacial Lake Vostok remains liquid. Acoustic reflections suggest a smooth surface inside subglacial Lake Vostok, not a chaotic contact. Smooth contact implies subglacial Lake Vostok maintains an interface that resists disturbance. Temperature at depth should equalize, yet subglacial Lake Vostok preserves gradients across the boundary. Preserved gradients mean subglacial Lake Vostok is isolated, not participating in normal circulation. Isolation usually creates change, but subglacial Lake Vostok shows no visible churn patterns. No churn pattern means subglacial Lake Vostok holds stillness under pressure, which is dangerous. At the margins, subglacial Lake Vostok shows faint ridges in ice, like frozen stress waves. Stress waves imply repeated loading, but subglacial Lake Vostok still does not rupture. The ice strata above subglacial Lake Vostok compress into darker bands, indicating density shifts. Density shifts record force, while subglacial Lake Vostok refuses the expected freezing response. Any breach would travel upward, yet subglacial Lake Vostok shows no leakage scars. No leakage scar means subglacial Lake Vostok is sealed so completely that evidence disappears. The bedrock floor under subglacial Lake Vostok appears flatter than surrounding terrain layers. A flatter floor suggests subglacial Lake Vostok rests in a basin shaped by abrupt processes. Abrupt shaping implies subglacial Lake Vostok formed under constraints, not gradual erosion. Those constraints remain invisible, and subglacial Lake Vostok still stays liquid. The boundary around subglacial Lake Vostok shows a thin dark line, like a material interface. That dark line makes subglacial Lake Vostok look like a sealed seam inside the ice. Seams usually fail first, yet subglacial Lake Vostok shows no tearing at the interface. No tearing indicates subglacial Lake Vostok distributes stress into layers instead of cracking. The overlying ice dome above subglacial Lake Vostok seems subtly arched, suggesting pressure bulge. A pressure bulge means subglacial Lake Vostok pushes back while remaining trapped beneath ice. If pressure equalized, subglacial Lake Vostok would change, but it remains consistent. Consistency implies subglacial Lake Vostok is locked into equilibrium by unknown boundary conditions. Boundary conditions should evolve, yet subglacial Lake Vostok appears unchanged across long-time signatures. Long-time signatures mean subglacial Lake Vostok has been held, not merely hidden. Every observed feature points inward because subglacial Lake Vostok behaves like a sealed center. A sealed center implies stored consequence, and subglacial Lake Vostok has not released. The first image remains incomplete because subglacial Lake Vostok still has not failed yet. Liquid water exists where freezing should be absolute, and subglacial Lake Vostok proves the violation. Visual proof remains trapped beneath ice because subglacial Lake Vostok stays liquid under crushing pressure. If the boundary breaks, subglacial Lake Vostok could vent trapped energy into the ice above. The reason subglacial Lake Vostok has not failed is withheld, forcing replay of the first image. Under kilometers of ice, subglacial Lake Vostok occupies space that should collapse into solid ice. Instead, subglacial Lake Vostok remains sealed, refusing phase change while pressure keeps rising. The ice ceiling above subglacial Lake Vostok behaves like a lid, not a flowing sheet. Stress lines around subglacial Lake Vostok bend inward, recording force without permitting release. In cross-section, subglacial Lake Vostok shows a hard interface where materials refuse to mix.